Hello everybody and welcome to the MLittleProgramming tutorial. Please drop a like on the video as it really helps the channel, and subscribe if you haven't already. Let's get into it. In today's video we're going to be looking at the two loop types in Python, for loops and while loops. First up is for loops. What is a for loop? A for loop is used to iterate over a sequence. A sequence can be a list, a tuple, a dictionary, a set, or a string. With the for loop we can execute a set of statements, once for each item in the sequence. A for loop can also be used to do a specific task a set number of times. So let's say we have a print statement, print MLittleProgramming. We know that we can print that once, but how would you print this 10 times? Maybe you would type this line out 10 times, but this method does not scale. So what about printing this 100 or 1,000 times? You can't just keep typing the print statement over and over, it would take too long. But what you can do is use a for loop. We can place this print statement inside of our for loop and get the for loop to execute this print statement a certain number of times. So the syntax for a for loop is to use the for keyword followed by a space. Next, we define a variable. This variable can represent the current item we are on whilst iterating through the list. This variable can also represent a counter. The syntax for both these options is the same. It's merely how you think about the functionality that you're trying to produce from the for loop. In the example of the print statement, we are going to call our variable I. Calling a counter I is commonplace within Python and the software development community more generally. The next piece of syntax is the word which links to our last piece of syntax, which is to tell Python the number of times we want to execute the sequence events within the for loop. This is the word in. There are a number of ways we can indicate to Python how many times we want to iterate over the block of code within the for loop. For this first example, we're going to use the range piece of syntax. The range function returns a sequence of numbers, starting from 0 and incrementing by 1 by default, and ends at a specified number. There are a number of variations of this function to change the defaults, and we'll look into those throughout the video. For now, we just want to print this print statement 10 times. So to do that, we pass 10 into the range function. After this, like in the if statement syntax we looked into in the last video, we end our for loop declaration with a colon. Following this, we indent the code we want to be executed every time the for loop is run. So we're going to type print MLittleProgramming. And if we run that, we can see that MLittleProgramming is printed 10 times. Let's say now that we want to print the numbers 1 to 10. So if we just replace the string MLittleProgramming with the variable I, the counter we've defined here. When we run this, we see that this prints 0 to 9, as that's the default for the range function that we've defined. What we can do to print 1 to 10 is to change the arguments that we passed into the range function here. For this, we're going to need 2 arguments. So when we have two arguments, the first argument is the start of the counter, and the second argument is the end of the counter plus 1. So to print the numbers 1 to 10, the 2 arguments we pass in are going to be 1 and 11. So let's print that now, and as you can see, this outputs 1 to 10. Now let's think about a different example. What if we wanted to print the 2 times table? So far we've been incrementing the sequence by 1, as that's the default for the range function, but in this case we want to increment by 2. The range function actually has a third parameter, in which we can change the amount we are incrementing by. So for the 2 times table, we'd want to start the sequence with 2 and end the sequence with, say, 20, 10 times 2. So we'd pass in 21 as the second parameter, and then the third parameter is how much we're going to increment by, so 2. As we run that, you see that we have printed 2 to 20 in increments of 2. We've now looked at both integers and strings, but for loops can also be used to iterate through lists. So let's define a list above our for loop. Let's use the list we used in the list video, so we use a list of groceries, apples, bananas and grapes. If you haven't seen that video, there'll be a link in the top right now and in the description down below. Following this is where we can use this variable here to describe the individual item in the list. So we can call it individual grocery, an item. We also need to change this range piece of syntax we've been using to the name of our list, so groceries. Inside this for loop, we can just print item, and this will print every item in the list. As you can see, when we run this, it prints every item in the list. But these for loops so far we've been looking at have been simple, and we've been happy to let them run until completion. However, There are use cases where we want to stop the loop before we iterate right to the finish we've initially declared. Let's add a few more items to this grocery list to make this benefit the syntax we're about to see a little bit more obvious. Okay, so I've added a few items to our list, and so now we have 10 items in our list. Let's say we want to check that we have bananas in this list. What we can do is place an if statement inside of this for loop. The if statement is going to do a string comparison between the current item and the string bananas. Inside this if statement, we're going to use the break syntax. What this break statement does is stop the loop, and then Python will continue to read the code in the sequence it was before the loop. We can show this by adding some print statements. We'll add one before we go into the loop, one as we enter the for loop, and one as we enter the if statement, and then one just after we finish the loop. So now we run that, let's just explain what happened, because there's a lot going on. So we enter the for loop once, we don't meet the criteria for the if statement, so we enter the loop again. This time, the second item in the list is bananas, so we meet the criteria for the if statement, and so we just enter the if statement, and that means we reach the break statement. This means that the loop stops, and then we continue with the code sequence, therefore it prints the outside if statement. Another piece of syntax that impacts the iterations of the loop is the continue statement. With the continue statement, we can stop the current iteration of the loop and continue with the next. So where is this useful? Well, let's take the example that we have with the break statement. We'll replace the break statement with the continue statement. This time we're also going to print the item after the if statement. Let's just run this and we'll go through what happens. So we enter the for loop, we don't satisfy the if statement, and so we print the first item, apple. We then enter the for loop for a second time. This time we do satisfy the if statement. What happens now is the continue statement means that we stop this iteration of the for loop, meaning we skip this print statement, and we go back to the start of the for loop for the next iteration. The for loop then continues, unaffected from here on out. When we're using for loops, we may also want to do something when the loop is finished. There is a piece of syntax for this, and that is using else. So for this example, we're just going to remove a few of the print statements to clear up the code. In fact, we're going to remove every bit of code inside of the loop, apart from printing the current item we're iterating over. The else is going to be on the same indentation level as where the for loop is being defined. Inside this else statement, we're going to print finish loop. As we run that, you'll see that every item in the list has been printed, and at the end, we've got our finish loop statement printed out. So far we've looked at both single layer for loops and lists. However, as we know from the list video, we can also have lists of lists. We can use these for loops to iterate through these types of lists as well, using a nested for loop. A nested for loop is a for loop inside another for loop. So we're just going to type out the skeleton structure of the nested for loop. We're going to put print statements inside both the outer for loop and the inner for loop to show how this works. For the moment, we're going to go back to using the range syntax. We're going to run the outside for loop 3 times and the inside for loop 3 times. So as we run through this, we can see what is happening. We enter the outer for loop, then we enter the inner for loop and iterate through it 3 times. We then leave the inner for loop and go back to the top of the outer for loop, printing outer loop. Then we go back to the inner for loop, printing inner loop 3 times. Then we do the same for the final iteration of the outer loop before exiting the for loop altogether. So now let's create a list of lists above our for loop and remove the 2 print statements inside of the nested for loops. On the outer for loop, we're going to iterate through individual lists inside list of lists. On the inner loop, we're going to iterate through the individual items in that list. Inside the inner for loop, we're then going to print that item. As you can see, when we run that, we're printing each individual item in the lists. And that just about wraps up the for loop section of this video. We're now going to move on to while loops. But first, what is the difference between a for loop and a while loop? So, for loops and while loops. In the last section, we looked at for loops. Now you may be wondering when to use for loops and when to use while loops. Generally, you want to be using while loops when you don't know when they're going to end and how long they're going to run for. Then you want to be using for loops for when you do know when they're going to end. For example, if you're doing an exercise, say running, and you want to know how far you can run, you could define a while loop that says, while not tired, keep running. This way, whilst you're not tired, the while loop will keep executing, and until you get tired, then it will stop executing. For loops, on the other hand, you need to define an endpoint or a range, so you need to say something like, if the distance is less than 10 miles, keep running. So to sum up, for loops are better if you know something, while loops are better if you don't. So let's hop into pycharm and look at the syntax of a while loop. To declare a while loop, we use the while keyword. Pycharm changes the colour of the while keyword, as it is a reserved word in Python. After the while keyword, we declare our condition. For this first example, we're just going to use the boolean value true. Then to tell Python we've finished declaring a while loop, we place a colon. After the colon, we want to define the body of our while loop, or what we're going to execute when the while loop is run. So we go on to the next line, following Python's indentation rule of 4 spaces. Inside the body of the while loop, we're going to place the print statement, print MLittleProgramming. Note, this is not good coding practice to write code like this, and I'm about to explain why when I run this. What happens when we run this is that because our condition to re-enter the while loop is the boolean value of true, of course this will never fail and will keep printing MLittleProgramming forever. This is what is called an infinite loop, and you should be careful to avoid these in your code. If you're experimenting with while loops and end up with an infinite loop, you can just end the process in pycharm by pressing this stop button just here. That was the most basic form of a while loop. Let's now get on to looking at while loops that don't end up with infinite loops. We'll start off by showing how to replicate a for loop using a while loop. So let's look at an example from the for loop video. I'll link that video in the top right now and in the description down below. Let's just count from 1 to 10. Now, unlike with the for loop, we can't define our variable within the declaration of the loop. We have to define a variable before the loop declaration. So we'll define our counter variable as I and initialize it as 1. Now we can declare our while loop. So while I is less than or equal to 10, colon, then print I, our counter, and then increment I by 1, each iteration of the while loop. To increment I by 1, we can either say I equals I plus 1, or we can say I, then a plus followed by an equal sign, then the amount we want to increment by, so 1. We're going to use the latter as it's easier to read. Let's run that and we'll see that we can print all the way from 1 to 10, and then when I reaches 10, we no longer meet this while condition, and therefore the while loop exits. At the start of the video, I mentioned that while loops are good to use when we don't know when the end of the loop will be. Let's now create a while loop where we don't define the end of the loop within the while loop declaration. Let's go back to the running example. We'll create a variable called tired, which is going to be a boolean value that we're going to initialize to false. Then we want to create a second variable called health, which will initialize to 10. In our while declaration, we're going to say while not tired. This is where I think Python's readability becomes really useful. In other languages, we'd have to make a statement like while tired equals false, but Python allows us just to use the implied logic from the name of our boolean value. So we can just write while not tired, which is almost exactly like the English equivalent. Then, in our while block, we're going to first decrease health by 1 each time we're in the loop. Now we need a way to change the status of the health variable whilst we're iterating through the loop. We're going to declare an if statement above where we are decreasing the health by 1. If you want to learn more about if statements, there is a video about that in this series. I'll put a link in the top right now and a link in the description. The if statement is going to ask if health is less than 2. If the health is less than 2, then we're going to set tired to true. We're also going to put some print statements in the while loop so that I can explain what is going on when we run this program. We'll put 1 as we enter the while loop, 1 printing our health variable on every iteration, and 1 when we enter the if statement. Let's run that and I'll explain what's going on. So we enter the while loop and we don't meet the criteria of the if statement. So we move on and decrease the health by 1. So health is now 9. We then come back up to this while condition and ask if we are not tired. And that is true because the health variable hasn't been altered yet. So we enter the while loop again and reach the if statement, asking if the health is less than 2. But of course that still isn't satisfied because health is 9. So we skip over the if statement and reduce the health variable by 1. The loop continues in this way until, as you can see, health equals 1. When health equals 1, we now satisfy the if statement and we can enter the if statement. This means we print inif, and tired is set to true. Python still reads the health minus 1 line, and we execute it, so health at this stage would be 0. But that doesn't matter to us in this case, because when we come back to the top of this while condition, we are now tired, and therefore we do not enter the while loop. Okay, so now we have this while loop that has a single condition and a body. We're now going to make this while loop a bit more complex by adding in another condition. In this while loop, we're now also going to check for the distance we run. So our while loop is going to be something like, while we are not tired and we run less than 10 kilometers, then keep going. So you can imagine this as if we were training to be able to run 10 kilometers. Obviously in this example, our goal would be not be tired before we've reached 10 kilometers in distance, and this while loop checks that. To implement this, we're going to define another variable above the while loop called distance, which we're going to initialize to 0. We can then go into the while loop condition before our colon, adding the word and. Again, making use of Python's similarity to natural language. We can then type a second condition. So we're going to type distance less than 10. Then, inside the while loop, we're going to want to increment this distance. We're going to increment the distance by 2 kilometers for every iteration of our while loop. We're going to print the distance, like with the health variable, on every iteration of the while loop. So if we run this program again, we'll see that we enter the while loop and we don't meet the if statement criteria. So we move on and decrease the health by 1. So health is now 9, but increase the distance by 2, bringing the total distance to 2. We then come up to the while condition and ask if we are not tired, and this is true because we haven't altered the tired variable yet. We also haven't run 10 kilometers yet, as we've only run 2. So we enter the while loop, and again reach the if statement asking if health is less than 2, but of course that isn't satisfied yet, because health is 9. So we skip over the if statement and reduce the health variable by 1, and increase the distance run by 2, bringing our total distance run to 4. The loop continues in this way until, as you can see, the distance variable equals 10. So now we have a while loop with 2 conditions and an if statement. Let's now look at nested while loops. We're going to do a simple nested while loop, and then we'll come back to this while loop to show how they can be used in more complex examples. So what is a nested while loop? A nested while loop is when you define a while loop inside a while loop. This can be useful, for example, when you've got 2 different counters that you need to manipulate. What you have to be careful with nested loops is that you don't create an infinite loop. So we're going to create 2 variables, I and j. These are going to be 2 counter variables. We're going to initialize both of these to 0. We're going to define our outer while loop as while I is less than 10. Inside this outer while loop, we're going to increment I by 1. Then, on the same incrementation level, we're going to define our inner while loop. The inner while loop is going to run while j is less than 2. Inside the inner while loop, we're going to increment j by 1. Next, outside the inner while loop, but still inside the outer while loop, therefore on the same indentation level as the inner loop declaration, we're going to reset j to 0 on every iteration. I'm also going to add 2 print statements so I can explain what's going on when we run this. So what happens when we run this while loop? As you can see, we enter the outer loop, incrementing I by 1. Next, we enter the inner loop. We iterate through this loop until j is greater than 2, so we iterate through this loop twice. Once j is greater than 2, we exit the inner while loop, moving on to the next line where we reset j to 0. We keep iterating through the while loops in this fashion until I is no longer less than 10, so 10 times. Let's get onto a more complex implementation of nested while loops, and that is this running example. We're going to count the amount of steps we're doing per amount of distance. We're going to say that there are 1,000 steps in a kilometer. So inside this while loop that is currently checking if a runner is tired, we're going to add another while loop. This while loop is going to add a step to our total number of steps for every iteration of the inner while loop. So to set this up, we're going to create 2 new variables, one steps variable that is going to track our current steps within this distance, and total steps, which is obviously going to be our running total. So we'll create an inner while loop that says while steps is less than 1,000, keep going. Inside this while loop, we're going to add 1 step to our running step counter and 1 step to our total step counter. This differs from the first nested loop example. This is because in this example, we don't have to reset our counter when we leave the nested while loop, as we're using the steps counter to decide if we should re-enter the loop or not, and a separate total counter that we're actually using to work out how many steps we're on, but that doesn't impact the while loop logic. We'll add a few print statements in the outer loop so that we can see the total steps and distance going up as the while loop runs. So if we run this now, and we see that as we run this while loop, the steps is increasing along with the distance. And that just about wraps up this video on Python loops. Thank you for watching this video. I hope you got a lot of value from it. If you would like more Python programming tutorials, there is a link in the top right now, and a link in the description down below to a playlist of Python programming tutorials. With that said, if you enjoyed the video, please drop a like as it really helps the channel, and subscribe if you haven't already. Also, if you've got any questions, drop a comment down below and I'll get back to you.